Well, hello and welcome to the Smells Like Money podcast. Join me, Suzan Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. This week's episode of the DooDoo Diva Smells Like Money podcast is sponsored by Welcome to the Future of Industrial Automation with Riot SCADA. Take command of your operations like never before. From oil and gas to energy grids, Riot SCADA adapts to your industry, providing a seamless and powerful solution. Monitor, analyze, and control your processes with ease. Their intuitive interface puts the power of information at your fingertips. With scalability to grow with your business, customization to meet your unique needs, and remote access for control anytime, anywhere, they empower your control and drive your success. The future of industrial automation is here. Transform the way you operate with Riot SCADA. All right. And in 3, 2, 1. Well, hello, everybody, and welcome to this week's episode of the DooDoo Diva Smells Like Money podcast. We are continuing our visit today with John Chrisman of Moliere, who also has a really interesting background in the public sector for wastewater treatment that we spoke about last time. And so I'm going to ask John, for those of you who didn't get a chance to tune into our last episode, just a brief history on his background to kind of set the stage for why John is so, how would you say, qualified to speak on the subject that we are going to be addressing today. And so with that, take it away, John.
Definitely. So I've been in the water and wastewater industry for about 17 years. I've done everything from construction to operations management. I've been uniquely given the opportunity to optimize wastewater treatment plants, specifically come in immediately after upgrades. And because of that, I've learned how to solve problems within complex plants very well. Because of that, I've also been challenged with some unique problems and became very good at researching solutions. And that's ultimately how I found my way to Moliere and using this innovative chemical-free technology to provide solutions to problems both in municipal wastewater and industrial wastewater. So really excited to be able to share my knowledge and my troubleshooting skills to use this really green technology.
Oh, well, thank you, John. Well, you know, on the last episode, we talked a lot about the effect of surfactants, but this time I wanted to do a dive into an issue that all plants have. And if they say they don't, then they're lying about it, as you know. And that is the problem of odor, or dealing with odor abatement. And even though odor, it's an issue that it's really hard to put a price tag on or a value of solving that problem for a wastewater treatment operator, whether you're on the municipal plant or in a private sector plant. But I think one must take a look at what about the productivity detriment or strain that puts on the operators. If you want to equate, time is money, for every single time that wastewater superintendent or operator has to field a call from an angry resident about it stinks. What are you going to do? And if that starts to happen day after day after day, and if it doesn't get resolved, then, oh, heaven forbid, the press gets wind of it. And then you've got bad PR to deal with. And just the complaints, if you had to spend a couple hours every day fielding those phone calls, imagine if that just went away, getting all that time back, how that would improve things. And so, since it's such a big issue, like I said, last time we talked about surfactants, I want to talk about odor and nanobubbles because Moliere has recently had a few projects, and we'll go into both of them, but I'd like you to address the one on the municipal side first, that it was a plant that experienced odor as a result of trying to do the right thing. And that was an upgrade to their existing plant in order to stay in compliance and meet community growth. And plus, I guess the plant was starting to reach the end of its, healthy life cycle and something needed to be done. But then it created a whole host of other issues, and odor being one of them. And the fact that the place that was creating the odor was in an extremely affluent area with multi-million-dollar homes. And so let's talk about that situation and applications of nanobubbles. And I also want to touch on a little bit about, maybe you can't, odor being a big pain point. Maybe there's some other pain points you want to bring in. But when we talk about bubbles, and you mentioned this last time about there's fine bubbles, and we think of that as being part of, aeration process and takes fine bubble diffusers. How people say, oh, I'm already using bubbles. Well, how do nanobubbles differ from fine bubbles in aeration? How can they work to help each other? And I guess it's not meant to replace the aeration, but it's meant to help, if I'm understanding this correctly, that they play nice together. And so maybe to touch on those points to help our audience understand those very distinct differences.
Awesome. Well, so I'll start out with odor. Odor is something that we definitely try to engineer out of wastewater treatment. Our systems are designed to minimize odors. If we have natural systems like lakes and ponds, they usually don't stink, and part of that is because those systems are in balance. So when we think about odor, we really have to go to the root cause. What is causing the odor? In a lot of our engineered wastewater treatment systems, one of the root causes is that we're overloaded. If we're looking at a lagoon system, it could be that there's just too much solids applied to that lagoon for what can naturally be removed. And therefore, we become overloaded. Another common cause of odor is low DO conditions. We have certain types of bacteria that reduce sulfur compounds and create hydrogen sulfide, which is the most common odor that we smell in wastewater treatment, which is that of like rotten eggs. So when we speak about odor, it's like we're trying to always engineer around it. And so we have to figure out, well, what changed? Why do we have odors now and we didn't have them before? And that's really where some of our innovative technologies can come in, such as nanobubbles. So nanobubbles are unique as that they're so much different than a fine bubble. Nanobubbles are about 10,000 times smaller than our typical 1 millimeter fine bubble that we use for aeration. Therefore, there really isn't a lot of mass of oxygen in a nanobubble. And we don't expect to do our typical aeration within a process. Instead, nanobubbles operate more as chemistry and improve the conditions around some of those odor causing causes, or those odor causes. So with that, I'll kind of go into a few of the examples of applications where odors are common and how nanobubbles can help out. And I'll start out with the city that you mentioned. that was during a plant upgrade, and ultimately the timing didn't work out so well, and they had to store a lot of their waste activated sludge adjacent to the wastewater treatment plant. Ideally, you'd be using those fine bubble diffusers to keep that sludge fresh, but that's not an option during construction. And so when that sludge sat, it became septic. And so a lot of anaerobic bacteria was taking over, including those that take sulfur compounds in the water and generate sulfide. So the great thing about the nanobubble technology is that we can be deployed quickly. Instead of needing large tanks with air diffusers, we can just use a pump and compressed air, regular compressed air. And we can add nanobubbles into that environment, changing it. And instead of favoring that bacteria that's creating those noxious odors, we favor the healthy bacteria that continues to break down that waste and keeps it stable and odor-free. So that was one way that we were able to help out with that particular customer during that, emergency issue. But how we can help out other customers, and similar to that, is that a facultative lagoon is something that we're pretty familiar with in the wastewater industry. Both municipalities, usually small, and industries such as poultry, dairy, use these types of lagoons to stabilize their wastewater before they use it for irrigation or discharge. One of the challenges to these facultative lagoons is maintaining conditions that are both anaerobic and aerobic to both oxidize the waste and break down the solids in the bottom. When these types of systems become overloaded, a lot of odors are created. That's where nanobubbles really come and help out. So facultative lagoons need to both be aerobic and anaerobic, and we really depend on algae to do a lot of the work for us. Algae in a facultative lagoon are oxygen generators. They are similar to our blowers and diffusers in the activated sludge process. So we're very reliant on light. We need light to penetrate deep into these lagoons. Well, when we become overloaded, we fill those lagoons up with sludge, negating any space that algae can live. And then we also coat the top of those lagoons with scum and oil and other contaminants, sometimes surfactants too, that prevent that light from penetrating. And the combination of those things really decreases the amount of treatment capacity in these lagoons, leading them to be wholly anaerobic and causing odor issues. Nanobubbles work to help break down the chemical contaminants that coat the surface, allowing more light in, and they also become a source between the solids and the liquids, really enhancing or activating the natural biological process in these lagoons, and really reduce the overload conditions and bring those systems back amount of solids in the lagoon. Ultimately, the goal is to get these natural systems healthy again. We want the algae receiving as much light as possible, producing the oxygen to help aerobically degrade these contaminants in the wastewater. And we also want healthy bacteria in that anaerobic portion of the lagoon that helps break down those solids, ultimately increasing the total treatment capacity. When we can get that full lagoon system back into balance, those odors will go away on their own.
Wow. So now when we were talking about an industrial, obviously this one that we're referring to, this lagoon, was at a CAFO, or a confined animal feed operation. It was, if I recall, it was poultry. We do know that poultry can give off a lot of odor, not just in the hen barn, but I can imagine the byproduct of the the little layers that we all love. So when we're talking about an installation like that, how is the technology actually deployed into the lagoon? Is it, like a barn? Is it like, what does it look like? And how does it actually get, I would say, for lack of a better term, attached into the lagoon? Or does it become part of the piping into the lagoon?
Definitely. So Molaire's technology requires three basic things. We require a pumped liquid flow. So in this case, we would need a pump at the lagoon to pump water out. We need a nanobubble generator, which Moliere provides. And then we need a gas source. And typically we're just using regular compressed air as the gas source. So ultimately, for a lagoon, we'd be pumping water out of the lagoon through a nanobubble generator and right back into that lagoon. One of the unique things about nanobubbles, because of their size, is that they actually have a charge to them. And so they actually repel each other in the water and they mix or go out into the lagoon basically on their own and diffuse like any other chemical from a high concentration to low concentration. We don't need to pump all the flow of the lagoon. We can actually just pump a small side stream of it and continually recirculate because those nanobubbles want to automatically go out into the lagoon and spread out. So it's kind of exciting that it's something that we're very familiar with when we operate lagoons is using pumps. So it's nothing too difficult to get a hold of or maintain.
So the mechanics of it sounds to me like it's very low maintenance and kind of simple. Well, obviously, the generator, the creator of the nano bubbles is probably the complex part of the secret sauce, the magic box. But it seems like the rest of the mechanics, it's a pretty simple thing to operate with, low installation time, low maintenance, low overhead to get it in place. And so that leads me to the question, if somebody is bringing this technology in, is this something that you would consider a capital equipment expenditure or an OpEx, or is it something that can be had on one of the popular things that's happening now is what they're calling treatment as a service, like software as a service, where, you're paying just to you're almost kind of like leasing the privilege of having the technology there for as long as you need it. So how can this technology become available?
Absolutely. So we actually offer both a CapEx option and what we call nanobubbles as a service, where we will provide the equipment for both long-term and short-term leases. So that really makes us flexible to different industries, as well as the municipal market. Everybody has different constraints to how they make purchases. And ultimately, we look at ourselves as chemistry without having a large truck showing up once a week to fill your tanks. I mean, we're able to make nanobubbles in situ in the wastewater without the need for any chemicals. So sometimes we fit better on an OpEx budget where there's an offset of power or chemical costs. Other times, I mean, we really fit on that CapEx budget where we are replacing some other option or during an upgrade of wastewater treatment plant. But the other benefit to this flexible model is that we're also available for emergency response, where a short-term immediate solution is necessary.
Which is great, because that is a great way for somebody to actually try this if they're dealing with a specific, like the first one we talked about, a very specific issue where they've tried all kinds of other things that, hey, they're going to be no better off, no worse, I would say no worse off trying this to see, hey, will this work? And maybe it just takes care of a short-term problem and they don't need it anymore. But then again, they may find, wow, this is a great way to dip their toe in the pond, so to speak, to see, wow, is that something that I should consider as a long-term solution? Or maybe it's going away, but we're planning on an upgrade to the plant next year. That, ooh, I can't keep it right now, but this is definitely something that I want to put into the design. And so I would think this is going to be of interest to anybody that's doing any type of design build or consulting engineering for either retrofits, upgrades, new builds, or solving problems on either a private sector side for manufacturing, because there is a lot of industrial wastewater, as well as municipal. So how can these folks get more information about these applications, or how perhaps they could get started with something to test the waters with you to see if it's an application? Or I love how you compared it to, you're not a mechanical solution, you're chemistry. It's chemistry, not, when we think about chemistry, we think of chemicals. My father was a PhD in chemistry. I'm thinking, oh, we're adding this chemical, or, what was like ferrous chloride, or, some of these other things, but it's chemistry, but not chemistry. But that was a great analogy, that it's changing the molecular structure in a way of, am I understanding this correctly?
Yeah. It's just very unique bubbles that have these really cool properties.
Yeah. That's just changing the whole environment in a way that we probably never thought was possible.
Definitely. Yeah. So really getting a hold of Moliere can be done in multiple ways. I would always say we spend a lot of time making sure we have as much information as we possibly can on our website, including case studies and videos regarding the technology and how it's being applied. One of the other ways that you can get a hold of us is to contact the water process engineering team at Moliere. And we do have multiple trailer packages for both testing out and figuring out, what is that right size? I know that in my career, I've had all sorts of neat trailers with equipment show up to my plant to test out the best dewatering, a new polymer, you name it. And we also offer that to our customers as a short term to make sure that they can prove it out to their board, to the public. And that's one of the great things that Moliere can offer.
That's fantastic. Well, John, thank you for, continuing the dialogue and addressing these things in our conversation on this subject of nano bubbles, because I find it fascinating. We need to find greener and more natural ways of dealing with an old issue. So it's, new solutions to old issues that are always going to be there. They're never going to go away as long as there's people on the planet. So here we have it. And so again, thank you for being on the show. And until next time, tune in again and keep it flowing. And a very special thank you again to this week's episode's sponsor. Welcome to the future of industrial automation with Riot SCADA. Take command of your operations like never before. From oil and gas to energy grids, Riot SCADA adapts to your industry, providing a seamless and powerful solution. Monitor, analyze, and control your processes with ease. Their intuitive interface puts the power of information at your fingertips. With scalability to grow with your business, customization to meet your unique needs, and remote access for control anytime, anywhere, they empower your control and drive your success. The future of industrial automation is here. Transform the way you operate with Riot SCADA. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.